Devitt of New Way Air Bearings, and I'm here at the Penn State Machine Dynamics Lab to investigate damping properties in air bearing films. So what we have here as a subject to study is a vacuum preloaded air bearing. It's 13 inches across in diameter. It's about 2 inches thick. We have about 80 square inches of vacuum area inside here and 35 square inches of air bearing pressure land at the perimeter. The two regions are separated by an ambient groove. We've laid the bearing down on its face, and we have an accelerometer on the back of the bearing. It's directly over the air bearing land. We have an instrumented hammer and a signal analyzer, and we're going to adjust the vacuum pressure and air bearing pressure in order to study the change in the dynamics of the air gap. The reason we are using a vacuum preloaded air bearing is because it allows us to load the air bearing films in a completely non-influencing fashion. So we know that any damping we might find is attributable to the air films, and it's not attributable to some structure that we may have coupled to the bearing in order to try to load the air bearing films. With 60 psi input pressure to the bearing and no vacuum force, the bearing is floating on a relatively unstiff air film. So there was an axial mode at 36 Hertz and a tilt mode shape at 50 Hertz. But when we applied 800 pounds of vacuum force, the first mode, the axial mode, went to 1000 Hertz and the tilt mode went to 1500 Hertz. The axial mode shape was associated with 6% damping, and the tilt mode was associated with 10% damping. So these are very high frequencies and very high damping numbers to be associated with a structure that's this large. The bearing's about 25 pounds. So it goes to show that air bearings have both a high degree of stiffness and a high degree of damping.